Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0172, indicates a rich fuel condition in the fuel system of the Honda Civic 2022 and later models. This rich condition occurs when the amount of fuel in the air-fuel mixture is too high for optimal combustion. It is crucial to understand that the Powertrain Control Module, PCM, monitors the long-term fuel trim, LTFT values. If these values fall below a specified threshold, the system recognizes an anomaly and stores the P0172 code. This DTC can indicate potential issues in various components of the fuel system and may lead to decreased fuel efficiency, increased emissions, and possible engine performance issues. Components such as the mass airflow, MAF sensor, oxygen sensors, fuel injectors, and others can be implicated in this rich condition. Proper diagnostics must be executed to pinpoint the root cause of this code. DTC P0172 reflects an issue related to long-term fuel trim, LTFT, where the PCM finds that the LTFT values are not within an acceptable range. The PCM is responsible for adjusting the air-fuel mixture to optimize engine performance and emissions. When it detects that the fuel trim values are lower than expected, it concludes that there's a fuel-related anomaly, thus storing this error code. Key components impacted include the MAF sensor, which measures the amount of air entering the engine, the oxygen sensors that monitor exhaust emissions, and the fuel injectors responsible for delivering fuel to the combustion chamber. These components are critical for maintaining a balanced air-fuel ratio, which is essential for proper combustion. Their locations include the intake manifold for the MAF sensor, the exhaust system for the oxygen sensors, and the engine near the combustion chamber for fuel injectors. Several factors could cause DTC P0172 to trigger. First, aftermarket fuel system and engine components may alter the design functionality of the vehicle, leading to abnormal fuel mixture readings. Next, specific issues with the fuel system, such as a failing fuel pump or tank unit, can result in excessive fuel supply, contributing to a rich condition. Additionally, a malfunctioning MAF sensor can misread airflow, causing the PCM to miscalculate the necessary fuel quantity, resulting in an unbalanced fuel mixture. Each cause affects the engine's ability to run efficiently and may lead to further issues if not addressed. Regular checks for aftermarket installations and thorough diagnostics of the fuel system components are essential. Symptoms associated with DTC P0172 predominantly include poor engine performance, characterized by sluggish acceleration or a rough idle. Additionally, drivers may notice an increase in fuel consumption as the engine compensates for the rich condition, negatively impacting fuel efficiency. The PCM turning on the check engine light is another common indication of this issue, signaling a need for immediate diagnostics. Some vehicles may also exhibit issues with engine emissions, leading to potential environmental concerns and failed emissions tests. Consistently monitoring these symptoms can help prevent long-term damage to the engine components. The first step in troubleshooting DTC P0172 involves starting the engine and allowing it to idle without any load. For continuously variable transmission, CVT vehicles, this means placing the transmission in park or neutral, while for manual transmission vehicles, it should be in neutral. This idle condition is crucial for obtaining accurate readings from the Honda Diagnostic System HDS. You will then check the short-term fuel trim, STFT value. Specifically, if the STFT value is less than 0.79, this duplication of the failure confirms that a rich condition exists. It's essential to note that the STFT gives a quick view of adjustments the PCM is making based on current engine conditions. If the STFT reflects a significant negative value, it indicates a rich mixture requiring further investigation. Following the initial check of the STFT, the next step is to review the Honda Diagnostic System HDS onboard snapshot, which captures engine performance data at the moment the DTC was set. It's essential to record the STFT value during this snapshot. This documentation is critical for understanding how the engine was performing when the DTC logged an error. The next part of this step involves a test driving of the vehicle under conditions similar to those prevailing when the DTC was triggered. During this process, you need to observe various parameters like engine speed, vehicle speed, relative throttle position, RELTP sensor readings, and accelerator position sensor APP readings. If you observe that the recorded STFT value exceeds 0.79 while driving, this confirmation indicates that the rich fuel condition issue is still present. The third troubleshooting step involves conducting a fuel pressure test, specifically evaluating the low pressure side of the fuel system. It's crucial to ensure that pressure readings fall within specified values, while the STFT is still below the critical threshold of 0.79. This test identifies any issues with the fuel tank unit or in the fuel pump circuit. Using the HDS, you will analyze real-time fuel pressure data. Results indicating abnormal conditions here will guide further diagnostics. Low fuel pressure can lead to an inadequate fuel supply, contributing to a rich fuel mixture, while abnormal readings may require additional in-depth examinations of the fuel delivery system. In this step, you need to inspect the high-pressure side of the fuel system. Start the vehicle and bring the engine speed to 3,000 RPM without any load until the radiator fan activates. This step is important as it simulates a more demanding condition on the fuel system. The next component of this step involves using the HDS to execute a direct injection DI fuel pressure test. It's crucial to verify that the results of this test indicate normal conditions. If the results deviate from expected values, you should proceed with troubleshooting for any related DTCs, such as P0087, low fuel pressure, and P0088, high fuel pressure, as this indicates a deeper issue within the fuel system that may contribute to the diagnostic code being addressed. Step 5 entails a functional inspection of the mass airflow MAF sensor, a critical part of maintaining the correct air-fuel mixture. Start the engine and allow it to idle while ensuring that the engine coolant temperature ECT sensor reading exceeds 158 degrees Fahrenheit or 70 degrees Celsius. The vehicle's transmission has to be in park or neutral, and all electrical loads should be turned off to secure stable readings. After these conditions are met, you must monitor the HDS for the MAF sensor readings while keeping the engine speed steady at 2,500 RPM for 30 seconds. Normal MAF values should lie between 4.1 grams per second and 5.7 grams per second. If readings fall outside of this range, it indicates there may be a malfunction in the MAF IAT sensor 1, which could contribute to the rich fuel issue being diagnosed. The sixth step focuses on an inspection of the engine oil for fuel contamination, an important evaluation as contaminated oil can lead to several mechanical issues. Start the vehicle, allowing it to idle before gently pinching the positive crankcase ventilation PCV hose to determine how it affects the fuel trip. Evaluating the STFT during this moment will offer insights into the effects of potential fuel leaks leading to oil contamination. A normal reading will show the STFT below 0.79. If it exceeds this value, further investigation into potentially faulty injectors or the presence of unburned fuel in the oil is necessary. Resolving oil contamination issues usually involves replacing the engine oil and oil filter to restore system functionality. This step is essential for isolating potential fuel quality issues as a cause for DTC P0172. Begin by installing a known good fuel source. This is crucial for determining whether previously used fuel contributed to the rich condition. Drain the existing fuel from the tank and replace it with a high-quality, certified fuel to see if the issue persists. After refueling, run the engine to reproduce the failure condition. If DTC P0172 remains flagged after using known good fuel, this suggests deeper issues in other components of the fuel system rather than just fuel quality. Conversely, if the symptom disappears, it confirms that the previous fuel was defective and contributing to the rich conditions seen in earlier diagnostics. In troubleshooting step 8, focus on the air-fuel A-fuel sensor, specifically sensor 1, to evaluate its impact on DTC P0172. Since there are no direct testing methods for this component, installing a known good A-fuel sensor is a common and effective diagnostic measure. After installation, monitor the engine's performance for changes. If the original failure condition replicates, it indicates that there are additional issues with other related components within the fuel system. Alternatively, if the symptoms resolve, it would confirm that the A-fuel sensor was indeed faulty and was contributing to the rich fuel mixture that triggered the DTC initially. Step 9 in the troubleshooting process involves evaluating the fuel injectors for proper functioning. Similar to the AF sensor, a known good injector should be installed to assess if it resolves the rich fuel condition represented by DTC P0172. Monitoring the vehicle's performance after the replacement will allow for determining if the previous injector was contributing to the elevation in fuel delivery, leading to excess richness. If installing a known good injector eliminates the DTC and associated symptoms, it confirms that the initial injector was at fault. Conversely, if the symptoms persist, you may need to investigate other related components in the fuel delivery system to identify further issues. The final troubleshooting step calls for an inspection of the Powertrain Control Module, PCM. This step is crucial as the PCM often regulates multiple systems within the vehicle. If earlier diagnostics indicated normal conditions for other inspection items, such as the fuel injectors, MAF sensor, and AF sensor, it can be assessed that the PCM may be the root cause of the DTC P0172. Use specialized diagnostic tools to evaluate the PCM for potential errors or irregularities in programming. If the module is found faulty, it will need replacement or reprogramming to restore proper operation. Correctly diagnosing PCM issues is essential to ensure that the vehicle can return to optimal operational status. After completing all troubleshooting steps and necessary repairs, it's vital to verify that the DTC P0172 no longer triggers and that the vehicle operates correctly. Begin by using the diagnostic tool to clear the DTCs from the system. Follow this with a comprehensive test drive to assess the vehicle's performance across various driving conditions. While test driving, meticulously monitor for any symptoms previously exhibited, such as poor engine performance or check engine lights. If everything operates smoothly without symptoms resurfacing, the repair can be deemed successful, confirming that the root cause of the DTC has been resolved. To prevent the occurrence of DTC P0172 in the future, engaging in regular preventative maintenance is essential. This includes routinely checking fuel quality before refueling to avoid moisture or contamination that can affect combustion. Regular inspection of air-fuel sensors and additional components such as the MAF sensor contributes to early detection of any irregularities. Furthermore, monitoring short-term and long-term fuel trim values can help identify potential issues before they escalate into larger problems affecting vehicle performance. Emphasizing preventive measures will not only aid in maintaining engine efficiency, but also extend the overall lifespan of your Honda Civic. In conclusion, DTC P0172 serves as an important diagnostic tool for identifying a rich fuel condition in the Honda Civic 2022 and beyond, signaling necessary repairs to maintain vehicle efficiency. Conducting a systematic troubleshooting approach, as detailed, is integral in identifying and rectifying underlying issues across various fuel system components. Throughout this process, it is vital to adhere to the recommended steps to avoid overlooking any potential factors contributing to the error. Ultimately, ensuring proper maintenance practices can help mitigate risks of future occurrences, optimizing both performance and emissions in the long term. Please like and subscribe to the channel. See you next time.